what's the fancy word? Displacement, yeah. Yeah, displacement. You have velocity. And you have acceleration. Now, when you have a formula that's in terms of any of these, like if you have x equals 2 times cubed, in order to figure out what the velocity function is for this, since you're going down, you're going to take the derivative. So the derivative of this function, which would be velocity, would be multiply that, and you get 6t squared, because you subtract. If you don't know how to do this, that's back in calculus with cheating rules. If you have any questions about that, just send me a message. And then if we want to get to acceleration from there, we just take the next derivative, the second derivative, which would be 12t. So if we were to map these on a line, on a graph, this one will be a straight line, meaning your velocity, because if this is your acceleration, and this is your time, this shows you the progression. This is wrong. Okay, scratch this. I'm not doing any cuts on this video, so deal with it. So if you're looking at a line, and this is representing your acceleration, that means that your velocity is going to look like that. And then this is going, as if you look, first you have a very small increase in velocity, so that means you're slowly increasing. Then you have a dramatic increase in velocity. And then eventually this would taper off, so you'd have what would look like a cubic function, a squared function, and a line. Okay. So to go the other way, we have to do the antiderivative. So if we're going up the ladder, we have to do anti. So if we're given a acceleration is equal to 12, no, that's one I just did. I'll say 2t. To find velocity, so if we're trying to find the velocity, this is all one function. This is all considering one situation for solving for given time, only time in getting your output. Because as you noticed in the other ones, you had on this side, you only had one of these, and on this side, your only other variable was time. So this means that whenever you have time, you can find this at any given time. So if this is 2t, to find the antiderivative, we raise the power and then divide our past coefficient. So this would be 1, so 1t squared. And then our displacement function would be, if you have 1 and you're raising the power, so it'd be 3, you end up dividing it by 3. So this is what these would look like. That's starting from acceleration and finding velocity and then displacement. So in actuality, if you did x, v, a, these two would switch. If you're looking at like a pyramid. Because in reality, this is just a pyramid where you have the largest functions down to the simplest functions. Because every time you go down the period, you reduce the degree. Because if we're starting up here, the degree is a cubic function, whereas then it goes to a square function and then a linear function. Meaning that down at the bottom is where you'd have the linear, because remember this is acceleration, this is the bottom of the triangle. And at the top, you would have the highest exponent, the highest degree, because in displacement, it is going to be the most complex. So up here is your x, and down here is your a. In the middle is your velocity. Now that we know how to figure out rules 1 and 2, antiderivative and derivative, we can look at rules 1, 2, and 3. All of these can be found on your formula sheet whenever you have any kind of test. Sorry, I have a small eraser. Okay, so your 3 formulas are for displacement at a given time, you have 1/2 times the acceleration times the time at that given moment squared plus your initial velocity plus your initial displacement. Oftentimes, whenever your velocity and displacement are 0, aka when it's stopping at rest and you're trying to figure out how far it's going, because that's what you're going to use this for. Because if it's telling you you have an object that's at rest and it goes a distance and you're trying to figure out how far it goes or what's its acceleration over a certain time period, this stuff normally goes away, because if you're just adding 0 and 0 because it's at rest, you can figure out delta x and then put that back into context. So we have, you're gonna hear that sound a lot, I'm sorry. So velocity plus displacement. So this is going to be whenever you need to find displacement or acceleration or time when you're not given an ending velocity, or when you're trying to find initial velocity or something like that. And then our next equation is velocity equals acceleration times time plus initial velocity. This one is pretty simple if you're looking at trying to find, if you just look at what variables you're using, because if you notice there's no displacement. So this is just finding one of these when you're not given an x or displacement value. And then finally, another one of the key ones. This one you won't use it as often, but these two are really important. Is v squared, or v subscript 1 squared, is initial velocity squared plus 2 times your acceleration times your change in x. Remember, if you don't have this, and you can find this from this if you know your acceleration and your time. So if you have your acceleration and your time, and you can substitute 0 for these, you can find your displacement, which you can also use to create this. So that's how you find velocity, would just have that stuff. So knowing this, we can move on to some of the problems. The first one is going to be 2.41 from Mastering Physics. And I'll post a picture of it so you can write it down and look with it, because my values are different, but I'll still read it to you. So it says a particle's acceleration is described by the function a equals, and yes, there's a subscript there, but that's just for letting you know that's in terms of displacement, is 10 minus t. And that's obviously meters per second squared is your units. That's why in parentheses and it says off to the side your unit. That's just letting you know what the units of A are. So this looks ugly, so we're going to fix it to -1 t plus 10. This makes it a lot easier to work with. Now that we have our function for acceleration, it wants us to find at what time is the velocity 0. Wait, first of all, when you look back at the problem and realize that our initial is not 0, it is 220. This will come important later. And all the other initials are 0, so those don't matter. So the velocity at 0, so we're trying to find v, and we have the equation for acceleration. So in order to go from acceleration to velocity, if we have x v a, if we know going down is derivative and up is antiderivative, since we're talking in terms of functions, velocity is right above acceleration, so that means we have to go up, which means we need antiderivative. So we're going to raise the value, or raise the exponent, and then divide. And then here, we just have to add the t. So now we know our function for velocity. And it wants us to know at what time is velocity equal to 0. So if it wants to know when this is 0, we can just plug in 0. Now 1/2 t squared plus 10t. And then here, this is quadratic formula stuff. Negative b, yes, you have to use all this stuff, plus or minus the square root of b squared, and then it's minus 4ac, but since there is no constant value, c is 0 and anything times 0 is 0, so we can just do that. And as we see, we have due to flower power over root, we have 2 as our exponent and as that number, fancy number, can't remember the name of it. So that's plus or minus 10. And all that is divided by 2a, which is -1. Now we already see, so if we're just looking at the top part, negative 10 plus 10 is 0, and 0 divided by anything is 0, so that's not a solution, so that doesn't matter. Because we know, because if that equals 0, that means our velocity is 0 at time 0, and we already know that because it's given in the prompt. So negative 10 minus 10, that'd be negative 20 over negative 1. And since you have a negative in the numerator and the denominator, that gets you 20. That tells you at 20 seconds, because this whole thing was solving for time, because that was our variable, is when v is equal to 0. So that's the answer to part A, using the values that we were given. To find part B, we have to plug it back in, except it wants to know what the particle's position is. So we have to figure out what the total displacement is after 20 seconds. Okay, so we have our velocity function, and we know that t equals 20. And we want to find for displacement. And again, following these rules, we know that we have to find the antiderivative. So we raise this and then divide it by. I'm using 0.5 so we don't have a ratio over a ratio. And then plus raise, and then 10 divided by 2 is 5. Okay, so we have our equation for a displacement, except one thing. We know that initially it is 220. So that means that's our constant. So we have to add 220 at the end. So do you want multiplying a time? It's x0. And so this is x1. So if you missed that, that's probably where you got this problem wrong. And then we just plug this into our calculator and get 886 point, yeah, doesn't matter because it's 6, yeah. And that rounds to 887 because they want us to round to 3 significant figures because that's how much they give you in 220. So I'm going to do 2 more example problems, and then if you have questions on any one, just let me know. I'm just going to put the phone down so I can erase. And if any of this doesn't make sense to you, ask for a specific part and I'll try to walk through it.